March 10, 1943, 01 to 6 hours, 20 miles off the Dutch coast. A moonless sky hangs like a black curtain over the North Sea as a lone RAF Wellington claws through sleet and headwind. The aircraft trembles under the weight of its bomb load, engines groaning, radio crackling with bursts of static that drown out the crew's shallow breaths. Below, searchlights sweep blindly, hunting for shadows they cannot see. The gunner wipes frost from his goggles, listening to the rhythmic cough of the Pegasus engines, while tracer fire arcs far beneath them, too distant to be a threat. Farther east, beyond the grey horizon, an American B-17 formation is already climbing out of English airfields, preparing for something Britain has refused to attempt, a daylight strike into the heart of occupied Europe. The contrast is stark, and neither side fully understands the gamble the other is making. RAF Operations Log, March 1943, hours later. As dawn's first pale line creeps across the English countryside, the American bombers rise in disciplined echelons, their wings glinting with icy condensation. Ground crews mechanics trained at Boeing's Seattle plants and the sprawling maintenance depots at Burtonwood watch the formations assemble with a mixture of pride and dread. Each B-17 bristles with .50 caliber guns. Its four right are 1820 Cyclone engines coughing to life, filling the air with a metallic roar that shakes frost from hangars. USAAF Maintenance Log, 1943. The mission orders are clear. Deep penetration into the Ruhr, Germany's industrial furnace. The planners of 8 Bomber Command believe daylight is the only way to achieve precision, striking steel mills, ball-bearing plants, and coking facilities that feed the German war machine. Britain disagrees, convinced daylight suicide runs will yield nothing but burning aluminum and empty bunks at mess halls. By early 1943, the debate has hardened into doctrine. Britain's Bomber Command, under Air Chief Marshal Arthur Harris, embraces the night, relying on darkness as its armor. The RAF has learned through blood thousands of aircraft, lost over the Channel in 1940 and 1941, that German flak and fighters dominate the daytime sky. RAF Loss Summary, 1942. Night operations, though wildly inaccurate, offer survivability. And survivability means pressure on the Reich's cities and morale. Meanwhile, the Americans under General Ira Eaker cling to the Norden bomb site and the promise of daylight accuracy. The device, refined by engineers like Carl Norden and Theodore Barth, claims it can drop a bomb into a pickle barrel from 20,000 feet, provided the target is visible. U.S. Army Air Force's Test Report, 1942. Both nations believe they are following logic. Both cannot be right, and Europe is about to decide which vision survives. On this cold March morning, German radar stations along the coast begin detecting faint echoes. First, the slow-moving signatures of British Wellingtons, then the denser, tighter blocks of American heavy bombers. The Luftwaffe controller at Stade peers at his scope, unsure whether he is watching two separate offensives or the movements of unrelated navigational flights. Luftwaffe Radar Log, 1943. Confusion threads through the reporting chain. Daylight raids had been expected eventually, but not with such boldness, not this deep, not with cloud cover broken and flak batteries fully rested. As the sun lifts, German pilots scramble from fields near Oldenburg and Jevor, engines screaming as ground crews signaled them skyward. They are prepared for nighttime interceptions, not for a duel against fortress bombers bristling with guns and flying in disciplined combat boxers. The skies over Europe are about to test both air forces' convictions. Inside the RAF bomber, the crew senses the shift before anyone says a word. The wireless operator listens to fragmented chatter. German fighters vectoring not toward them, but toward the B-17s approaching the Ruhr. RAF Wireless Log, 1943. For the first time in the war, two distinct Allied strategies converge in the same morning sky, each shaped by hard lessons and national identity. Britain, hammered during the Blitz, views nighttime bombing as a shield against German air superiority. America, entering the conflict with vast industrial confidence, believes military targets must be struck with surgical daylight precision. Their doctrines reflect their experiences, one born of necessity, the other of optimism. As the Wellingtons drift homeward and the American streams push deeper into Germany, the contrast becomes sharper. Like two halves of an unresolved equation scrawled across the continent's airspace, German commanders on the ground realize what this means only gradually. Reports from flak towers in Essen and Duisburg describe American bombers approaching in rigid boxes, maintaining formation even as the first bursts of black flak blossom around them. Flak Regiment 38 report. 1,943 pilots in the Luftwaffe's Jagdgeschwader. One complain of dense defensive fire, a wall of intersecting .50 caliber streams that forces them to break away before closing to lethal range. To them, the idea of assaulting such fortresses in broad daylight seems reckless, even arrogant, yet the Americans press forward. Their belief in visibility and precision is total. Meanwhile, German civil defense crews, trained to respond to RAF night raids, scramble in confusion. Sirens wail too late, and cities brace for a style of attack they have rarely faced in full daylight. Above the continent's fractured morning haze, the two doctrines collide not in a single moment, but in the growing realization that air power itself is being rewritten. The RAF crews who survive the night return to bases lit only by dim lamps, recording their impressions with weary hands and frostbitten fingers. RAF Squadron Diary, 1943. The Americans, still hours from home, pressed deeper into hostile airspace, convinced their tight formations and defensive fire can overpower whatever the Luftwaffe throws against them. German observers, staring upward from city rooftops, struggled to comprehend the audacity. Daylight bombers slicing through the sky, unhidden, unflinching. Each minute tightens the tension between these competing visions of modern war, and by the time the first bombs fall on the Ruhr, one fact becomes unavoidably: one strategy will survive the crucible ahead, and Section 2 will reveal why. The truth waits just beyond the coming fire now. The darkness that shielded Britain for years became the very element the Americans challenged, and by early 1943 the truth behind that defiance began to surface in briefing rooms, factory floors, and engineering bays where the quiet architects of modern air power shaped the tools that made daylight possible. The RAF relied on night to survive, but the USAAF relied on machines built to endure sunlight, flak, and fighters without breaking formation. The transition from doctrine to reality started with a single advantage: the Germans never fully anticipated interlocking firepower and precision optics, engineered to function only in the clarity of day. Technical Manual TM 1-120, 1943. Inside those bombers, the Norden device sat on its stabilizing platform, a gyroscopic instrument crafted by Dutch engineer Carl Norden and refined by American technicians under strict secrecy. Its rotating prisms, adjustable crosshairs, and automatic stabilization allowed the bomber to correct drift and wind speed in real time, something impossible in the blind chaos of night. USAAF Bombing Accuracy Report, 1943. To make its promise real, Boeing engineers reinforced vibration mounts, modified cockpit airflow, and added dampening brackets that kept the bombsight aligned even when flak burst dangerously close. The device was not a miracle, but operated with ruthless logic. Visibility plus stability produced accuracy, and accuracy justified daylight. Defensive strength formed the second pillar. The B-17 carried up to 13.50 caliber Browning guns, each hammering at nearly 800 rounds per minute, creating intersecting arcs that made frontal and rear assaults costly for the Luftwaffe. Bowing Armament Field Notes: 1,943 American engineers like George Hyde and Frederick Moore perfected feed mechanisms and barrel change procedures that allowed crews to maintain continuous fire despite freezing altitudes. In dark workshops from Seattle to Wichita, toolmakers aligned gun mounts with micrometer precision. Their invisible labor translated into lethal geometry in the sky, giving the bombers a fighting chance. Communications formed the third edge of America's hidden advantage. FM radios, produced by companies like Motorola, delivered stable, static-resistant signals that allowed formations to coordinate altitude, heading, and turret focus while under fire. Signal Corps Equipment Report: 1,943 German intercept operators noted with frustration that the transmissions maintained clarity even during jamming attempts. With formation leaders broadcasting crisp commands, the combat boxes responded like synchronized machinery. RAF bombers at night could rarely coordinate with such cohesion, forced instead to navigate through darkness with minimal radio use to avoid detection. But it was in the factories that these advantages took shape. The Detroit industrial matrix, Cleveland's engine plants, and California's precision instrument shops produced engines, turrets, radios, and bombsights at a tempo the Luftwaffe could not match. War Production Board Bulletin. 1,943 thousands of machinists worked night shifts, sharpening cutting heads, forging crankshafts, and assembling optics with bare hands rubbed raw by solvents. Their craft, multiplied across states, transformed technical theory into durable machinery capable of carrying daylight doctrine into enemy skies. The full power of this hidden advantage emerged during the climactic raid of April 17, 1943, when the USAAF struck the Focke-Wulf factory at Bremen. At dawn, 115 B-17s of the 1st Bombardment Wing lifted into the pale light, engines thundering as ground crews stepped back from the vibrating runways. 8th Bomber Command Mission Log. April 1943. Clouds drifted across the North Sea, but visibility remained strong enough for the Norden sights to be effective. The German radar network detected the waves early, yet controllers hesitated, unsure whether the Americans intended to penetrate so deeply again after previous losses. That hesitation would cost them dearly. Approaching the Frisian Islands, Me-110s and FW-190s rose to meet the intruders, slicing upward through fractured cloud layers. Their first passes tested the American defensive web, diving from above, firing in short, lethal bursts, then pulling away before the returning .50 caliber fire could shred their wings. Luftwaffe. Intercept Debrief. 1943. As more German fighters swarmed, the combat boxes tightened, maintaining altitude and speed with machine precision. Veteran pilots later described the sight of gun flashes rippling across staggered formations like a metal storm. Every turret, every gunner, every pivot mount built in quiet American factories now performed under the harshest scrutiny imaginable. At 10:23 hours, with Bremen's outskirts visible through gaps in the clouds, the lead bombardier opened the Norden's stabilizer arms. He adjusted drift, wind speed, and target crosshairs as flak detonated around the formation, shaking the aircraft with blasts of black smoke and flame. Bombardiers after-action notes. April 1943. German gunners, trained to track RAF night raiders by sound and silhouette, fired with hectic urgency at the bright silver formations overhead. Yet the bombers held steady, trusting the Norden and trusting the interlocking guns to keep fighters at bay long enough to reach release point. Bombs spilled downward at 10:41 hours. Steel casings tumbled through sunlit air, whistling between drifting cloud fragments before striking factory roofs, assembly halls, and machine bays within the Focke-Wulf complex. USAAF strike photo analysis. 1943. Engineers later confirmed that key machining centers, jigs, and wing assembly stations were damaged or destroyed, disrupting production of the formidable FW-194 Weeks. For the first time, German commanders admitted in internal memos that daylight raids possessed a precision no night attack could match. Reich Ministry Technical Brief. 1943. The cost, however, was severe. Luftwaffe fighters pressed relentlessly through the withdrawal, scoring hits on engines, wings, and tail assemblies. Several B-17s spiraled downward trailing smoke, bursting into flame before disappearing into the haze. 8th Bomber Command Casualty Report. April 1943. Yet even as formations thinned, they maintained cohesion. The surviving bombers crossed back over the North Sea, still firing at pursuers, their gunners exhausted, frostbitten but unbroken. German pilots returned to their bases with conflicting emotions. Some expressed grudging respect in written debriefs, noting that the American formations had become flying fortresses in truth during the battle. Others displayed frustration and disbelief that such massive aircraft could hold their formations under that level of pressure. Luftwaffe. Pilot Diary. 1943. Dramatized composite. The Reich's air defense doctrine, optimized for night interception and independent fighter sweeps, struggled to counter formations that used technology, coordination, and firepower as a unified shield. By the time the last B-17 landed on English soil, mechanics swarmed the damaged airframes, patching holes, replacing guns, and restoring engines with practiced efficiency. Burtonwood Depot Maintenance Log. April 1943. Their labor ensured the daylight offensive could continue, sustaining a strategy Germany still lacked the tools to counter. And this technical foundation, forged in factories and tested over Bremen, would soon reshape the psychological and strategic landscape of the entire air war. The aftermath of Bremen rippled far beyond the wreckage of its workshops, echoing through strategy rooms, intelligence centers, and the minds of commanders on both sides of the war. What emerged from that raid was not merely damage to a factory, but a revelation. Daylight precision, once dismissed as reckless optimism, could create pressure Germany could not counter with speed or adaptation. Britain watched with a mixture of admiration and concern as the American daylight offensive gathered force, knowing their own night campaign was essential but inherently different. Air Ministry analysis. 1943, the two approaches, once conflicting, began forming a grim symphony of destruction that stretched across months of relentless bombing. Germany's leadership felt the strain first. As raids intensified through the summer of 1943, internal reports described factory workers arriving late, production lines stalling, and supervisors struggling to maintain morale under the constant threat of daytime attack. Reich, Labor Ministry Memorandum. 1,943 workers, who once feared night raids, now feared the sudden roar of engines at midday, the trembling of glass, and the cracks of flak guns echoing across industrial districts. The psychological shock of having no hour safe from destruction eroded confidence in the Reich's ability to defend its own skies. American crews, by contrast, drew strength from the clarity of their mission. Each daylight strike produced reconnaissance photographs, measured blast patterns, and damage assessments that validated their sacrifice. USAAF Reconnaissance Archive, 1943. Unlike night bombing, where cloud cover and navigational drift often obscured results, the daylight campaign delivered visible proof of impact. Air crews could study frames showing burning refineries, shattered ball-bearing halls, and cratered rail yards. These images bolstered morale across bomber groups and reinforced faith in engineers, gunsmiths, and instrument makers whose work enabled survival. Meanwhile, RAF crews felt a different pride. Their nightly journeys through darkness remained essential, saturating German cities and disrupting the civilian infrastructure that fed the industrial base. RAF Bomber Command Review. 1943. Many British aviators saw themselves as ghost-like figures striking where no daylight bomber dared, operating in a realm of shadows that demanded its own courage and skill. The two forces, once philosophically divided, were becoming complementary blades cutting from opposite sides into the same hardened target. The merging of the campaigns produced effects German analysts struggled to quantify. When night attacks left cities burning and daylight raids struck factories before repair crews could work, the compounding damage slowed output across steel, chemicals, synthetic fuel, and aircraft production lines. Speer Armaments Report. 1944. The Luftwaffe faced a brutal dilemma. Fighters needed to defend daylight skies, yet fuel shortages and damaged plants, limited training hours, and reduced aircraft replacements. Every day that bombers struck deep targets accelerated this spiral. Yet the cost for Allied crews remained immense. Bomber groups lost men at rates that strained replacements, and maintenance crews worked constantly to repair flak-torn aircraft. 8. Air Service Command Log. 1943 ground technicians often labored through cold nights, replacing hydraulic lines, aligning propellers, and patching aluminum skins drilled with hundreds of holes. Their rigorous routines, shaped by industrial standards and relentless checklists, kept the daylight offensive alive through periods when losses threatened to halt operations entirely. The decisive psychological shift arrived after the Schweinfurt-Regensburg missions, when American bombers, though bloodied, demonstrated their ability to cripple ball-bearing production critical to German armaments. U.S. Strategic Bombing Survey. 1946 German factory managers wrote of workers trembling as daylight descended, aware that protective trenches and shelters offered little reassurance when factories themselves were targets. German pilots expressed fatigue from constant scrambles, dwindling stamina, and the terrifying realization that even successful interceptions could not prevent bombs from falling. Luftwaffe Pilot Debrief. 1943 dramatized composite. The Reich's air defense system, stretched between night and day, began cracking under the strain. Allied intelligence noted something darker as well. Morale fracturing within German cities. Many civilians no longer asked if a raid would come but when. OSS Civilian Impact Assessment. 1940. For the combined pressure of day and night assault created a grim rhythm that eroded psychological endurance. Firefighters, medical crews, and industrial supervisors found themselves working continuously, unable to rest or rebuild before the next wave approached. For them, the war's violence no longer moved with the cycle. It became a constant presence. Inside Allied planning rooms, leaders recognized that Germany's defenses, logistics, and morale were weakening in tandem. Coordinated operations RF by night, USAAF by day were increasingly planned to exploit repair cycles, weather gaps, and fuel shortages. Combined Chiefs of Staff Directive, 1944, engineers refined aircraft further, adding faster charging oxygen systems, improved turret rotation motors, and reinforced wing spars. Every innovation reduced casualties and increased striking power. The war was being shaped not only by pilots but by welders, draftsmen, metallurgists, assembly line workers, and instrument makers whose contributions rarely reached the headlines. As months passed, the strategic picture grew increasingly clear. The relentless tempo of bombing forced Germany to disperse factories, move machine tools underground, and divert manpower into repairs instead of production. Jägerstab Recovery Report, 1944. These changes slowed output dramatically. When Allied ground forces finally crossed into Germany, many captured facilities displayed scars from both night and daylight raids: charred walls, broken cranes, shattered skylights, and empty assembly lines covered in dust. The combined bombing campaign had achieved what neither strategy could alone. The legacy of this dual doctrine extended beyond the war's end. American emphasis on daylight precision evolved into the analytical bombing concepts of the Cold War, influencing the development of radar-guided strikes, advanced navigation systems, and later, the smart weapons of the Gulf War. Air War College Lecture Notes, 1958. Britain's mastery of night operations shaped electronic warfare, Pathfinder tactics, and counter-radar innovations that foreshadowed stealth doctrine. Together, the two sides of the air campaign formed the foundation of modern aerial warfare: precision guided by visibility, survivability guided by darkness, and strategy shaped by the integration of both. The human cost, however, remained the story's most enduring shadow. Tens of thousands of airmen never returned from the skies above Europe. Their sacrifice was supported by ground crews who toiled without pause, by engineers whose hands built every rivet and gear, and by families who waited in silence for news that too often never came. U.S. War Department Casualty Notice, 1945. Germany's civilians endured terror, dislocation, and loss on a scale impossible to articulate. The story of daylight and night bombing is not only one of strategy and production, but of the human soul under extraordinary pressure. In the end, the difference between Britain's night raids and America's daylight assaults revealed a timeless lesson about war itself. Innovation is never singular. It rises from thousands of hands, hearts, and minds working in unison toward a purpose shaped by fear, hope, and necessity. And as one American pilot later reflected, in those skies, daylight and darkness were just two sides of the same blade. Veterans Oral History Project, 1952, dramatized the blade, carved the fate of a continent, and its shadow remains.